Hello dear students, welcome back to Aja Physics. In the last video of motion in straight line, we have seen what you mean by distance covered and what you mean by displacement and what is the difference between them and what are all the different types of questions that can be asked in JEE about those topics. In present video, I will go to the next concept of the same chapter, which is nothing but the speed. Speed is simply a measure of how fast or how slowly a body is moving with respect to a reference point. Now, therefore, the speed can be defined as the rate of distance covered with respect to time is called as speed. Now, I will tell you what is the unit of speed and what is the dimension of speed as well, and then we will go to the types of speeds. So, dimensions are very clear. So dimensions of speed is nothing but m to the power 0, because speed is nothing but the rate of distance covered with respect to time. So there is no question of mass here. So therefore m to the power 0, L to the power 1 and t to the power minus 1. So these are the dimensions of speed. Now let's talk about different units of the same speed. So units are, first I will tell you SI units of speed. SI unit of speed is meter per second. Okay. So as the unit itself is indicating, or it is talking about speed, it measures what is the distance covered, means how much of distance measured in meters with respect to the time, with respect to unit time. That is what the speed is actually. Now this is nothing but SI unit of the speed. SI unit, standard international unit. And there are other units like centimeter per second. So where centimeter is not the SI unit of length. Okay. And also we can measure usually while you are traveling in any vehicle, the speed of the vehicle is measured in kilometer per hour. Here both the unit of distance and unit of time, they are not in SI. Okay. So these are all the different units of speed. Now there are two types of speeds we have. The first one is uniform speed and the second one is non-uniform speed. Let us understand these two by using this simple diagram. Imagine that this is a straight road where a car is traveling along the straight road. So here along the straight road, along the straight path, the distances are mentioned. From here to here it is 5 meters. Similarly, 5 meters equal intervals. The road is divided in equal intervals of space in distances. Now, similarly, assume that the car is covering this 5 meters in 1 second, next 5 meters in the next 1 second, 5 meters in 1 second, and all the 5 meters in every 1 second for each 1 second. Then how to calculate the speed? Speed is nothing but 5 meters per second. You will say that's why the speed is called as 5 meters per second. Similarly, the next speed is, the speed of the car when it is traveling for the next 5 meter is 5 meters per second only, because it is traveling 5 meters by taking 1 second of time. In the same way, the next 5 meters along the same straight road are with the same speed 5 meters per second always. This is called as the car is said to be traveling in uniform speed. Okay, so where the speed is constant, that is called as uniform speed. Okay, the motion in which speed is constant is called as uniform speed. I hope you understood this scenario properly. Similarly, this is non-uniform speed. Non-uniform speed means the body is traveling at different speeds in the same straight road. Say for example, the first 5 meter is covered in 1 second, but in the next 1 second the car is traveled 8-meter distance. So here the speed changes. So in the first 5 meter, in the first 1 second, the speed is going to be 5 meters per second. But over here, the speed is going to be 8 meters per second, because 8-meter distance is covered with respect to 1 second. That means by taking a time of 1 second. Therefore, the speed is going to be 8 meters per second. The speed increases. Similarly here also, in the picture it is very clear, 10 meter is covered in 1 second of time. So therefore speed is 10 meters per second. Similarly 4 meters per second and 6 meters per second. So if the car is traveling at different speeds, it is called as non-uniform speed. So basically, if the car covers equal distances in equal intervals of time, then the speed of the car is said to be uniform. If the car is covering unequal distances in equal intervals of time, or ulta also is possible, equal distances in unequal intervals of time, that is also possible, then car is said to be have, or anything is said to have non-uniform. Now to understand the concept of speed in a better way, let us have this example very clearly. This is a straight road where the road is not uniform everywhere. There is a hump over here in the road, and in the same straight road, maybe the road having lot of irregularities, uneven, okay, that kind of road it is, but the path where the car is traveling or the vehicle is traveling is a straight road. Now assume that when the car is here, the time is going to be t1. This is nothing but the initial time. Now the car starts moving in this direction with a particular speed, and because of the hump over here, the car will get slowed down. I mean, the speed of the car is going to decreases because of the hump, and then after the hump the car will increase its speed till the irregularities or uneven road is going to come, and because of this irregularities in the road, the car speed is going to reduce again, and then car will speed up and finally reaches this position. The total distance traveled by the car from here to here, I will call the distance as delta S. Okay, here S stands for distance covered. Delta S is nothing but it is representing a certain space interval along the straight line. That is what this delta is. By the time car reaches this end in the straight road, let us say the time is going to be t2. Now, how to calculate? If you calculate the ratio of distance covered by the car divided by the time taken, the time interval to reach from here to here, okay, the total time for the journey. You can calculate the total time for the journey as t2 minus t1. T2 minus t1 will give you a time interval, okay, for the journey. You can also call or write this as delta S divided by T2 minus T1 as delta T. This is nothing but time interval or time taken by the car to go from here to there. This ratio is called as average speed. Okay, this is called as average speed. Usually average speed is represented with the letter V, so which can be written as delta S divided by T. So this is nothing but the definition of speed, or this is how we are going to calculate the speed. Now along with this average speed, there is one more we need to understand. If you calculate, say for example, the total distance the total distance traveled by the car from here to there, say for example 100 meters, and divided by the time taken by the car to reach from here to there is 10 seconds, for example. So how much is the speed is going to be? Speed is going to be 10 meters per second. It does not mean the car has always traveled with 10 meter per second speed throughout its journey. Okay, this is just the average speed. How do we calculate the average speed? We are not concerning about what was the speed near the hump. Okay, when the road was clear, what was the speed? And when the road was irregular, what was the speed? We did not consider anything about that. Simply, what is the total distance covered divided by what is the total time taken. This is called as the average speed. You will get average speed as something, say for example 10 meters per second. That doesn't mean the car is always traveling at this speed, okay, in the journey. Now assume that if you want to calculate the speed of the car at a particular instant and at a particular position, say for example immediately after the hump, maybe the car is here, this is the position of the car, When the car is moving from here to here to a small displacement by taking a small interval of time. Now I am not taking the entire time interval to calculate the speed. I'm interested in calculating what is the speed of the car only over here at this instant of time. The speed of the car at a particular instant, at a particular position is called as instantaneous speed. Now how to calculate instantaneous speed and how to express it in the mathematical way, that I will tell you. So let us calculate instantaneous. I will write speed is equal to, what I said about instantaneous is at a particular instant. That means we are not considering the entire time interval, but the time interval is going to be very short. So therefore, I will use this way. So limit that delta t is tending to 0. Delta t tending to 0 means the time interval is not equal to 0, but it is approaching 0. I mean, the time interval is very small, really small. If the limit delta t tending to 0 of this average speed, I mean of this formula delta s divided by delta t, you can also write this as, you can write this entire thing as ds divided by dt. Okay, so this will give you the speed of the body at that particular instant in a given position, at some position, or the speed of the body when it travel a very small distance ds in a very small time interval dt. Okay, this is called as instantaneous speed, which can be expressed using this equation. So you see that instantaneous speed is nothing but the differentiation of distance or position with respect to time. Okay, now let's understand this average speed in a more generalized way. There are such cases when a particle or when something is traveling at different speeds at different intervals of time. For example, this is a car traveling at the speed v1 in the time interval t1. Similarly, it is traveling with different speed v2 in the next time interval t2, and so on. There are different speeds at different intervals of time. In such cases, how to calculate the average speed? See, as the name itself indicates, it is average speed. If you take the average of all these speeds, then it is going to be wrong. We should always go with the definition of average speed. We know that average speed is always defined as the total distance covered by the body divided by the total time taken to cover the distance. This is what actual or the must and should used to be used formula to calculate the average speed. So what to do? Now to calculate the total time, it is very easy in this case actually, because what is the total time taken by the car to go from here to here? It is nothing but the sum of all these time intervals t1, t2, t3, t4. So therefore, total time for the journey of car is nothing but t1 plus t2 plus t3 plus t4. That is finished, because four time intervals are given. Sum of all the time intervals will give you the total time of the journey. But what about the total distance, which is not mentioned in the problem? Still, we can calculate the total distance covered. I will use the general formula for the speed. You know that speed is nothing but distance divided by the time taken. So therefore, distance can be calculated by taking t to the other side. So over here, how much distance the car has traveled in the time interval t1, that can be calculated multiplying the speed with the time interval itself. So therefore, the distance covered by the car in the first time interval t1 can be written as s1, which is nothing but v1 into t1. Similarly, car has traveled some other distance in the time interval t2, that can be written as s2, which is going to be v2 into t2, so on. Likewise, you can go on writing s3 as that different speed in that different interval of time, and s4 is equal to v4 into t4. Adding all these distances will give us the total distance. So therefore, total distance covered by the body is going to be s1 plus s2 plus s3 plus s4. So therefore, this is the total distance covered. Now, by taking this total distance divided by the total time, we will get average speed. So I will write the formula for average speed over here. Total average speed in the entire journey of the car is given by S1 plus S2 plus S3 plus S4. In these places I can write it as V1 T1 plus V2 T2 plus V3 T3 and so on up to nth term if n velocities or speeds are given. So V4 T4 divided by T1 plus T2 plus T3 plus T4. Okay, so if you are calculating the average speed when different speeds are given at different time intervals, then calculation of average speed will be done by using this formula. So therefore, this type of speed, average speed, is called as time average speed. Let us understand this by taking an example. So here there is a simple example based on time average speed. There is a particle moves for 20 seconds with a speed of 3 meter per second, and then it is traveling at the speed of 4 meter per second for the next 20 seconds, and then finally 5 meter per second for the last 20 seconds. So what is the average speed? So here the body is traveling, or a particle is traveling with different speeds 3, 4 and 5 meters per second for for the time intervals of 20 seconds each. So I will go with time average velocity formula, time average speed formula. So time average speed is given by V1 T1 plus V2 T2 plus V3 T3. Okay, the product of speed and the time will give us the distance covered. So the distance covered in each 20 seconds with traveling with different speeds divided by T1 plus T2 plus T3. Here all the time intervals T1, T2, T3 are exactly same, which is nothing but 20 seconds. But V1, V2, V3s are different. It is 3, 4 and 5 meters per second. So that question will be very easy to solve. So V1, I will take this T1, T2, T3 as common, which is nothing but 20, and I will open the bracket, and inside the bracket I will sum up all the speeds. V1, V2, V3. V1 is 3 meters per second. Okay, this is what V1, and V2 is nothing but 4 meters per second, and V3 is nothing but 5 meters per second over here. Okay, that divided by T1, T2, T3, which is nothing but 20, 20, 20. So 20 is 3 times. So 20 and 20 is getting cancelled. The average speed is going to be 3 plus 4, 7, 7 plus 5 is 12, 12 by 3 is 4 again. So 4 meters per second. This is the average speed. Okay. Now it's time to understand distance average speed. In some example, a particle or a body is traveling along the straight road at different speeds at different space interval. That means, for example, this car is traveling with a speed V1 for a distance S1. And then for the next space interval, say for example, for the next distance covered S2, the body is traveling at different speed V2. And for the next distance S3, the body is traveling at the speed of V3 and V4 for S4. Then how to calculate the average speed? So once again, average speed, I should not take algebraic average of all the given speeds. No, average speed is always defined as the total distance divided by the total time taken. Here the total distance is actually easy to calculate because each distances for each speeds or for different speeds are given. S1, S2, S3, S4 and so on. If you add all these distances, okay, for different given speeds, you will get the total distance. So therefore formula is very simple: S1 plus S2 plus S3, S4 and so on divided by the total time taken. That time is not given, we have to calculate the time here. So just take this one space interval, I mean the speed V1 for the distance covered S1. You can calculate what is the total time taken by the body to go from here to here with this much of speed. I will use the same definition of the speed. Speed is nothing but distance divided by the time. So therefore time is going to be distance divided by the speed. So if you want to calculate how much time the car has taken to go from here to here with this much of speed v1, we can call the distance s1 divided by the speed v1. This is nothing but t1. Similarly, for each these speeds at different what you call distances, you can calculate the corresponding time as t2 is equal to s2 divided by v2, and t3 is equal to s3 divided by 3t, and so on it will go. So therefore average speed can be written as distance by time. Distance is already written, divided by time I will write. Time is nothing but t1 plus t2 plus t3. In place of t1 I will write s1 divided by v1, s2 divided by v2, and so on up to the given terms or n number of terms. Okay, this is how, or this is the formula for distance average speed. Let us understand. Here is an example to understand distance average speed. There is a car which covers 2 by 5th of the total distance with the speed v1. v1 is not given. And next 3 by 5th of the distance with the speed v2. Then how to calculate the average speed? Here two speeds v1 and v2 are given at different distances. Say for example, if the total distance is for example x, and 2 by 5th of the total distance with the speed v1, and the next 3 by 5th of the total distance with the speed v2. So I will calculate, I will go to use this formula, distance average speed. So that means total distance divided by the total time. So here two speeds with two different distances, therefore two time intervals t1 and t2. So total distance is anyway, it is taken as x divided by t1. t1 is nothing but distance divided by speed. Now to calculate t1, I will write distance. First distance is 2 by 5th of the total distance. So 2 by 5th of the total distance, and this whole divided by the speed v1 plus, this is the first time interval, and the second time interval t2, which is given by, once again, distance by speed. Distance is 3 by 5th of the total distance. So 3 by 5th of the total distance divided by the speed. With what speed it is covering the next? That is nothing but v2. Okay, so this is what actually the formula for average speed. You can take this x common in the denominator. So x divided by 2 by 5 times v1, okay, plus 3 by 5 v2, and I will take this x common from the two terms of the denominator, and this x will be cancelling with this. So this is how we are going to calculate the average speed. If suppose the values of this v1 and v2 are given, you can just substitute them and you will get a particular value. Okay, now dear students, it is time to solve some MCQs based on the same concept, speed. Here is the first problem. There is a girl, she is in a metro station and found that escalator is not working. She walked up the escalator, stationary escalator, in time t1. Okay, this is very important. On the other day, if she remains stationary on the moving escalator, it takes her up in the time t2. Okay, so then time taken by her to walk up on the moving escalator will be. So in the first case, escalator was at rest and she managed to go up by walking the stationary escalator in time t1, and in the other day, if she is stationary or remain rest on the moving escalator, it will take her up in the time t2. What if escalator is also moving and she is walking? How much time it will take? And there are four options are given, and all these options are in terms of t1 and t2. This problem can be solved based on average speed only. Let us calculate the speed with which this girl can walk. Now assume that the escalator is bringing her from ground floor to the first floor. The height is h. Okay, so that the speed with which the girl can walk is v1, which is going to be that height between the two floors divided by the time taken. This is what the speed. This is when escalator was at rest and the girl is walking by taking time t1, and the speed of the girl is v1. So you can still write this as t1 is equal to h divided by v1. Now assume that if she is at rest on the escalator with respect to escalator, and escalator is taking her up in time t2, then what is the speed of the escalator? That can be calculated by using this formula, v2 speed of the escalator, which is given by the same height divided by the t2. So therefore you can write t2 is equal to h divided by this v2. Now escalator is moving and girl is also walking on the moving escalator. So there are two speeds now, and she managed to go to the upstairs by taking time t, and that can be written as the same height is reached by the girl divided by, now the speed is not just v1 or v2, she is also moving and escalator is also moving, so therefore two speeds in the same direction, the total speed is going to be v1 plus v2. Now I hope you can calculate what is the relation between this time. Okay, this is what actually asking in the question, and how it is related to this t1 and t2. I'll take the inverse of this equation, which means if t is equal to this much, 1 by t can be written as v1 plus v2 divided by h. Now v1 by h is nothing but 1 by t1, v2 by h, that is nothing but 1 by t2. So therefore finally this equation can be written as 1 by t is equal to v1 by h. v1 by h is nothing but 1 divided by t1 plus v2 by h, because this h is common for both the terms in the numerator. So this is going to be 1 divided by t2. So this is actually the relation between this time which is asking in the question and t1 and t2. So which option is correct? Actually option C is correct. So therefore if you solve this equation for t itself, you will get t1 plus t2 divided by t1 t2, or t is equal to t1 t2 divided by t1 plus t2. So option C is correct. This is one more question. A cat moves from x to y with a uniform speed vu. Here u stands for initial, something like that, and return to x with the uniform speed vd. The average speed for this round trip is, there are four options are given. So I will assume that this is x and this is y. The cat is moving from x to y with the speed vu, and it is returned to x with the speed vd. So we have to calculate the average speed now. To calculate the average speed, I'll go with the uh, formula of average speed, which is nothing but the total distance covered from x to y and back to x, which is nothing but 2 times of xy divided by the total time taken. Total time taken can be calculated in this way. Time taken by the cat to go from x to y as t1, and time taken by the cat to return to x from y, that is t2. So let us calculate what are these t1 and t2 and substitute that, we will get the answer. So t1 I will write here. So t1 is nothing but the time taken. You know how to calculate the time taken? Time taken is nothing but the distance divided by speed. So time taken by the cat to go from x to y is nothing but the distance xy, and whole divided by the speed with which it was going. It was going at the speed vu. So therefore this is t1. Similarly t2 can be calculated in the same way. The same distance but in the opposite direction, but here direction is not what you call significant. So therefore distance is same as before, divided by the speed is different. The speed with which it was coming is v. So I will substitute two of these values over here to calculate the average speed. Average speed is 2 times of xy divided by t1. In place of t1 I can write xy divided by vu, and here it is xy divided by vd. This is nothing but t2. So you can take this xy common from the denominator, both the terms of the denominator, and it can be cancelled with this, the xy in the numerator. So therefore average speed can be obtained as 2 divided by 1 divided by vu plus 1 divided by Vd. So finally you can write it as average speed in the total journey as 2 divided by, I'll simplify this. This will be Vu, that's Vd, and whole divided by the product of these two. I will take that to the numerator directly. So Vu into Vd. So this is the average speed of the cat in the entire journey. So option 1 itself is correct. This is the correct answer. Here is one more interesting problem. Two boys are standing at the ends A and B, where the distance between AB is nothing but small letter a. The boy B, the boy who is standing at the B, he starts running in a direction perpendicular to AB with a speed V1. The other boy standing at A starts running simultaneously with the speed V and catches the other boy. So time taken by this process is t, and we have to calculate the value of t, and the 4 options are given. So let us picturize this problem first. Here I will take the 2 points A and B, and the two boys are standing over here. The distance from A to B is nothing but capital letter A. Over here, the boy who is standing at B, he start running perpendicular to AB over here with a speed V1, and simultaneously the boy standing at A is also running with a speed V, so that he is going to catch. This is the speed of this boy who started from A. So we have to calculate the time t at which the two boys are meeting at this point. So this can also be solved by using the concept of speed only. How? You can imagine that this is nothing but a right angle triangle. This is adjacent side, and this is opposite side, and this is hypotenuse. So therefore, you can always write, you can imagine this point is C. You can write hypotenuse square in this right angle triangle. It is equal to adjacent square plus opposite square. Opposite square is BC whole square. So how to write distance in terms of speed and time? Here AC is nothing but the distance from here to here. So that distance can be written as the speed with which the boy at A start running to catch the boy who was running from B. So that speed of that boy multiplied by the time taken and the whole square, that will be equal to A square plus BC square is there, BC square. This distance can be written as speed of the boy who has started running from B multiplied by the time, that whole square. So now we got the answer. We can simplify this to get the value of this t. So therefore v square t square is equal to a square plus v1 square t square. So you can further, I will take this term. So you can write it as v square t square minus v1 square t square is equal to a square. I'll take this t square common. So t square, and inside the bracket it is v square minus v1 square is equal to a square. So finally t square is equal to a square divided by v square minus v1 square. So but I want t only, so therefore the final answer you can write it as t is equal to square root of this. So square root of a square divided by v square minus v1 square. So correct option is this one, option B is correct. So this is how we can use the formula of average speed